Hello everyone, welcome back to the computer network series. So in our previous video, we have seen the third type of protocol, that is go backend, right? And we have seen the disadvantage also. What is the disadvantage? It is creating congestion, right? Means if just one packet is lost, it is resending all the packets which are there in the current window, right? So how can we improve this disadvantage? Let's think before going on to the protocol. Let's first rethink how can we improve if we are there. So what if I am there in the situation and I am sending multiple packets to the receiver, and if receiver has not acknowledged second packet, then I'm not sending all the packets again. I'm just sending a second packet, right? So that I will do. So now what is this fourth protocol is doing? How it is solving this issue? This protocol name is selective repeat. How the name suggests, selectively repeat the thing. It is also doing the same thing. If the packet is lost, it is just selectively repeating that packet only. So in go back and it retransmits all the packets, and in selective repeat it just retransmits the packet that is lost. This is the main difference. Rest everything is just same. Okay, in go back and we are multiple frames are sent, and if acknowledgement is not being received, then sender sends all the frames that are there in current window. Okay, in selective repeat, sender sends multiple frames, and if the receiver has not acknowledged one frame, it sends that frame again. Okay, second thing is, in go back and we have the sender's window size 2 to the power m minus 1 and receiver is 1. And in selected repeat, sender window size and receiver window size both is 2 to the power m minus 1. Both is exactly the half of 2 to the power m. Okay. So now, then how receiver will send us packet? Now, if sender sends 4 or 5 packets at one go, receiver may have received first the fourth packet, then first packet, then second, out of order. It may receive, right? So what receiver will do? It will send out of order packets to the application layer? No. It will just collect that packet until if fourth frame is received, then it receive first, then it receive two, then it receive three. So it keep on collecting until the consecutive set is being received. Then it sends 1, 2, 3, 4 whole set to the application layer. Okay. Why this window sizes to the power m minus 1? That will be discussed later. First, let's see the working. And one thing again that is changed is acknowledgement number. Here in go back and or in previous protocols also, what acknowledgement number is? It repeats, it tells, okay, so now I have received packet number 1. Now here just send me packet number 2. Okay. Here selected repeat acknowledgement number say if sender sends packets 1 to the receiver gives acknowledgement, okay, I have received packet 1. Okay, so here acknowledgement acknowledges the packet it received, not the next packet it wants. Okay, that's the difference between selective repeats and go back. Now let's see the working. Here, let's suppose we have 8 frames to be sent and window size of sender and receiver is 4. Okay, so let's see what's happening here. Okay, first it starts 0, 1, 2, 3. Window size is 4, so it sends packet 0, 1, 2, 3, packet 0, 1, 2, 3 to the receiver. Okay, and receiver has received packet 1, data delivered to the application. It received and it delivered, because packet 0 means the first packet only. It is of order. It is of correct order, right? First packet, it has to be 0 only. So it sends that packet very easily to the application. Okay. Then it slides to 1, 2, 3, 4. Okay. Then acknowledgement also came and it slides to 1, 2, 3, 4. Okay, very nice. Then again it starts the timer. It sends then one packet, but the packet is lost, means it has not been received by the receiver. In between only the packet is lost somewhere. Okay, then packet 2 is sent. Okay, then packet 2 is sent and the receiver receives a packet 2 and sends an acknowledgement. Okay, I have received packet 2, but the window will not shift. Why? Because it has not received 1, it has received 2. It is out of order, right? Then sender sends the packet 3, packet 3 is sent, then packet 3 acknowledgement has come. Okay, window will not shift it, packet 1, 2, 3, 4. Okay, so now what happens? tells ki, okay, now I need 4, 5, 6, 7, but I have received, but packet 1 acknowledgement is not being sent by the receiver, right? So timer ends here, timer expires here. What will the sender do? If it was there in go backend, then it will send all 1, 2, 3, 4 again, right? What is there in the current window? Here it is just sending one. Packet 1 is resent, and once the receiver received packet 1, its order is completed 1, 2, 3. So now it delivered 1, 2, 3 in order to the application layer, and now it wants packet 0. It acknowledge, okay, I received packet 1. Now window slides and it slides to 4, 5, 6, 7. Now it again sends 4 and all. Again, this cycle continues. Okay. So we understood what is happening here. Receiver accumulates the packets until it is arrived in order. Okay, then it sends the ordered packet to the application layer. And what sender is doing? Sender just resend the packet that is lost, that the acknowledgement has not came and the timer expires. Okay, so that is happening in selective repeat. Now let's see the window thing. Okay, so here let's suppose you have the window size is 2m minus 1, means m is equal to 2 here. So what you have 2m minus 1, that is, you have 3, okay, or you have 2. If the window size is 2 to the power m minus 1, or the window size should be greater than 2 to the power m minus 1. Okay, so let's suppose here you have this 4 frames, right? And 4 frames you have, and exactly the half of 4 is 2. So you have the 2 window sizes 2. Okay. So what's happening here is 0 and 1. Okay. Timer starts. It sends packet 0 and packet 1. Now receiver receives packet 0. Acknowledgement has been sent by the receiver, but has not been received by the sender. It is lost somewhere. Okay. Windows shifts 1, 2. Then packet 1 it receives and Windows shift to 2, 3. And sender has not received any other acknowledgement till now. Okay, timeout. Then what sender will do? It sends packet 0, then receiver will correctly discard it. Why? Because it wants packet 2 or packet 3, right? Not packet 0. And what's happening here is, if the window size is 3, then what's happening is 0, 1, 2, and it receives packet 0, 1, 2. It sends acknowledgement of 0, window slides, then sends acknowledgement of 1, window slides, acknowledgement of 2, window slides. Now window slides to 3, 0, and 1. Means it can receive any of the packet from 3, 0, and 1. And timer expires, sender sends packet 0, and it can accept packet 0 because packet 0 is there in the window. But this packet and this packet is very different, right? So it has to be discarded, but it is accepted by the receiver. So the window size should be exactly half of this. Okay, so the sender window size and receiver window size is exactly half here. Okay, so that's the difference between go backend and selective repeat. It just selectively repeat the packet that has been lost. Okay, so now we have completed our 4 protocols, 4 unidirectional protocols. Simple, stop and wait, go backend, and selective repeat, right? Now let's see the bidirectional protocols. Okay, how we can convert this into bidirectional protocol. Let's discuss that. In real life, data packets are flowing in both the directions, right? In the 4 protocols we have discussed, that is unidirectional. Data packets are flowing from sender to receiver. But in real life, data packets are moving from sender to receiver to sender also, in both the directions, right? So there is a technique called picky banking that can improve the efficiency of bidirectional protocols. Means whenever a client and a server, whenever a client sends a packet to server, it will send acknowledgement also. And whenever server is sending a packet to the client, it will send acknowledgement also. Means both of them behaves like a sender and a receiver, both, right? So here you can see the implementation of go back and in bidirectional. Whenever a client sends this, it sends an acknowledgement also. And it have a client send window also and a client receive window also. Here the server also have a receiver window and a server window, receiver window and a client window. Okay. So whenever a client is sending a packet to receiver to the server, it adds an acknowledgement to that also. And whenever server is sending, it can add acknowledgement also. So by this, we can have bidirectional protocols. Okay. So that's the end of the chapter. We have discussed all the type of services that a transport layer provide. Then we have discussed the protocols also. We have discussed 4 unidirectional, and we can convert that into multi-directional to bi-directional also by the technique of piggy banking, by sending acknowledgement also, by adding acknowledgement also, and by adding both the windows to the, by client side, you can add both the windows, client also of receiver also, and at receiver end, you can add the server window also and the client window also. So the piggy banking, you can have those unidirectional protocols to bidirectional protocols. Okay. So now this is the end of this chapter, transport layer. Now we will see the different protocols of the transport layer, TCP, UDP, all these protocols we will discuss in our next videos. Okay. So thank you.